Okay, hello guys. The video actually starts later on. I kind of thought adding this in because I didn't explain too well in the video. But this is some prior knowledge that would be good to know if not covered in your physics class yet. And it would be very helpful during when I talk about the four-stroke engine. So on this heat graph, if you don't know what all these lines are already, is different processes happening in the four-stroke engine, but there are terms to describe the processes right here. Like from A to B that represents on this graph, we have ourselves isobaric. And we know that, as we can see, the pressure stays constant. So that's what describes isobaric process, is when the pressure stays constant throughout whatever is happening right here. And as you can see, the pressure staying constant and the volume's increasing. And the next important one we have to talk about is isovolumetric. And I guess that's kind of self-explanatory because we just saw one about pressure, so we're going to see one about volume. And isovolumetric is pretty much just a constant volume. And you usually see the pressure going up or down with these ones. And what the other important one we're going to have to know is isothermal. Isothermal is a nice curve like this, which I drew horribly. And what it represents is the volume will either be increasing or decreasing, but the temperature will be staying the same. So thank you for listening to this. I hope this little lesson helps for the four-stroke engine tutorial. To the four people that are going to watch this video, I'm back at it again and making another physics video. This video is going to be a little more toned down because I'm just doing it by myself, so let's get at it. Today, we're covering a topic in physics that I learned about pretty recently, that is heat engines. And the specific one we're talking about is going to be a four-stroke engine, and which is pretty much the one that you have in your car. So this lesson is going to encompass all the four processes of a heat engine, four-stroke engine, because it's a four-stroke engine for a reason. There's four different processes that go on: your intake, your compression, combustion, and exhaust. So this is why I have this graph here, because in physics, instead of studying the awesome engine, we have to look at a graph instead. So let's start off with intake, and I'm going to transition to the picture that makes it easier to look at / diagram. So here it is. We have the intake process right here where my mouse is fluttering around. So first process, this is going to be the first process. So we have this intake valve right here that starts the whole process. Intake valve opens at A, as seen right here. And when that intake valve opens, an air-fuel mixture rushes in at a ratio of 14:1. That being air first, fuel the 1. So 14 parts air, 1 part fuel. That rushes out and does work on the piston that pushes it downward, which is pretty much the whole intake stroke. That's why we see in this heat graph we have A to B, which just increases in volume and nothing else. Moving on to the compression stroke. So our compression stroke is from B, that looks just formed because I wrote it that way, and up to C. Another simple process as simple as intake. So time to just look at the heat graph and see what it does before we look at the diagram, which I would like to look at first. No, we're going to do that first. So right here is our compression, and as you can see from the intake, it moves up in the compression. The piston moves up the top dead center right here, which compresses the air-fuel mixture into a small confined area, which is why we see in the heat graph the volume decreases and the temperature or the pressure, its temperature stays the same because this is an isothermal process. So in this process, that's all it is just compressing. Guys, I guess I'm back. That was a horrible voice just then, but I wish I didn't have to talk through this video, or I would have just typed went along with the video and put some nice background music to it, but I guess I gotta follow the rubric, or I kind of lost the rubric already. So now let's start talking to the next. Oh, I started acting all crazy just then because we're talking to a heat graph for a second. Well, technically I am talking to heat graph because I'm talking to the camera, the microphone. Not the camera, but the microphone. So let's start with the compression stroke / power stroke. So with this power stroke, this is the process from C to D all the way down to E. So we got ourselves an isobaric process right here. Oh no, sorry about that. That's actually isovolumetric because the volume stays consistent while the pressure is increasing. Yeah, my sickness is getting to me. Sorry about that. And we got from D to E our isothermal process. So let's get started of how this actually works in the engine. So this is where we go to our diagram over here. So we got our diagram for our power stroke. So it's pretty simple. Spark plug ignites our air-fuel mixture, which creates heat, which what heat engine's supposed to do, which pushes down the piston, which is pretty much the power stroke, because that's pretty much what it is. C is where the spark plug ignites air-fuel mixture, and instantaneously the pressure increases due to the explosion, and it pushes down the piston from D to E, which is pretty much water break, which was pretty quick this time because I brought my water bottle up. So now we're just going to talk about the last part of a heat engine, the exhaust stroke, or we call it the exhaust. So this is the very important process because without this, nothing would be running because the gases would just be stuck in the engine forever. So with this one, pretty easy to explain is, as clearly we can see from E, B to A, the gases after it hits bomb dead center cool down, and from B to A, the piston itself pushes the gases out because that's when the exhaust valve opens to let the old gas out, as seen in this diagram right here, which pretty much explains the exhaust stroke. It's a pretty basic concept. And then everything resets to start the whole cycle over.